in the water to meet each other, to at the other end of the spectrum, something like a corn plant, where the sperm and the egg never contact the outside air, never have to swim through water or anything else. It's completely independent of standing water. So you have complete dependence on standing water at one end, independence of standing water at the other. That's the basic story, the evolutionary story of the origin of the plants. And if you look at the actual data, the similarities that group the groups together. So why do you separate the Horneophytopsida from the rest of them? There's a particular character there at 3b, which is possessed by all of the other, actually at 2b, by everything other than Horneophytopsids that unite them and thus suggest that they have an evolutionary common ancestor, and so on down the line. If you look at the list of characters that are used to define each of these things and separate out from those characters those that have to do with things that help a plant become more and more independent of water, something that helps it move water, helps it to stand straight above the substrate or so on, this would be what they would look like. I'm just going to flash through them. You won't know probably what most of these things are. But this is an example of the kinds of characteristics that are found at these various levels that help these particular plants, in contradistinction to the others, being more and more capable of existing independently of water. Now, if you take that cladogram that we had before, ignore all the characters that weren't useful for a plant to become more and more independent of water, you create another cladogram a little bit simpler that looks like this. Therefore, from this, you can actually now create a rank, an expectation of ranks of increasing terrestriality. Not evolution now. We're not talking about evolution. We're now talking about ecology. How do these plants differ in their ability to exist independently of standing water? So those with a high rank, a 7, are those that least need standing water to survive. And those that have a 1 up there actually require standing water in order for the egg and the sperm, for example, to swim together. And from this now we can produce an order of terrestriality that we can now compare with the evolutionary order. And the rank correlation there is actually just a little bit better. Not that it makes any early difference in 0.994 versus 0.995, but it's again what we're seeing then in the fossil record, getting a little bit closer to the actual data, is that the plants are entering the fossil record in increasing terrestriality. It's a measure of increasing terrestriality. Add one more thing to it, which is interesting. Not first appearance, which you would be interested in evolution. But if you're interested in ecology, you might actually be more interested in the time when the plant is most abundant, when the diversity is greatest, the center of its ecological, where it exists, the centroid of its ecological existence. For example, you might have a polar bear and a grizzly bear. They might actually overlap in geography. But most polar bears and most grizzly bears actually don't live in areas that overlap. And there's a clear order in grizzly bears when you go from the equator, where you've got a sun bear, to, as you go north, you get larger and larger bear species as you go to the largest bear species, the polar bear. And there's a certain order to the first latitude, the lowest latitude you first encounter that. But there's much more significance to actually where each bear species is most abundant geographically. And so maximum diversity makes sense ecologically. It doesn't make a lot of sense evolutionarily. But maximum diversity also correlates with the fossil record order. So the combination of the fact that terrestriality and maximum diversity both correlate with the order in the fossil record suggests that the plant divisions show not only an evolutionary order, but they also show an ecological order. So this could actually be a sequence of ecologies that actually make sense. They're a sensible ecological sequence. Now, when a geologist sees this sort of thing, paleontologist in particular, sees a sequence of fossils that are in an ecological order, they immediately think, one possibility here is that there is a transgressive sequence where sea level is rising and picking off an ecological sequence in succession. There's a number of things in geology. Whenever we see a certain set of rocks in sequence, if we see a gravel followed by a sandstone, followed by a shale, followed by a carbonate, we think, sequence. That's a sequence you would expect on a seashore, where the gravel is up above the beach, the sand is on the beach, the shale is offshore, and the carbonate reef would be farther out. So if the ocean is moving on land, it's going to leave that sequence, an ecological sequence of rocks. And it would also leave the ecological sequence of fossils in the rocks where they lived. So this immediately suggests maybe there's an ecology that is picked off by the flood in a sequence that would make sense of this. What ecology would this fit? Well, now here's where my own strange background comes into play. Back when I was about 12 years old, I was invited to go with a biology graduate student to a quaking bog. I had never been to a quaking bog, and I had no idea what this meant, but it was a field trip. It was fun. We got out of the car. This was in Indiana, and we climbed up and down these very, very steep, very high hills for quite some distance. They're actually really old sand dunes, about 200 feet high, that are covered with forest. Can't tell they're sand dunes. You would only know that because of context and so on. Otherwise, we're just going up and down, up and down, up and down. And we're in the middle of this oak hickory subclimax forest. Beautiful place. It's similar to where I grew up, and so it was fun. And then I noticed the forest changed, not in the type of plants, but in the fact that it was now very flat. We are no longer having to go up and down. That's what I noticed. You don't have to do as much work to walk through the forest. And at one point, the biologist who's leading us said, "Okay, everybody stop. Everybody grab hands. And what we're going to do is we're going to go up and down at the same time. As I go up, you go up. When I go down, you go down." Hey, this guy's lost his rocker. He's all right. What is going on? So here's everybody trying to do this, and there was a certain up and down. And at first, I say, I just hope no one's watching us. And then I realized, wait a minute. The ground is actually giving way under us. And the ground is going up and down. And it's going up and down in sequence with us. And then I began to realize that as we went down, and then came back up, it would create a wave that would go away from us, 360 degrees in all directions. This wave in the ground would come to a tree, and the tree would, and then as it goes away, and it's like, where are we? Until it transported to another planet. And I realized, wow, maybe the reason this forest is flat is because it's on top of a body of water. We're floating. This is a floating forest. This is crazy. If I hadn't been there, I just wouldn't have been able to believe it. As we walk then further, stop the bouncing. We walk then further out towards the center of the lake. As we did, the trees got smaller. The ground under us became less and less firm, and it got to where you could do it all by yourself. You could move the ground. A little bit further, you realize if you did this too much, you'd probably go through, and it's scared a bejeebers out of me. So, about the time it gets down to very short trees, you're a little bit concerned about walking on it. And so you begin hands and knees. You're walking across there, and then when it gets down to tall bush cranberries, and then short bush cranberries, now you're really concerned. And at this point, I'm out there on my belly, and I'm crawling around, and I'm looking directly at sphagnum moss and these beautiful Venus flytraps, and it's magnificent. And then you could see, as you went out towards the middle of the lake, it's open water. And obviously you can't go any further, or we would go go through. This was my experience with a quaking bog. And it really made a big impact upon me, and I never forgot it. The basic idea is